Thank you, everyone, and thank you for that kind introduction. It always feels nice to sort of come up here, rock star music blaring, right, hands up in the air. But this is not a rock concert. I'm going to talk to you about AI and data science teams and how to scale them out. So I think you guys are probably here because you're interested in learning about AI and data science teams. And when we think about what we can achieve with data science and AI, this is kind of what we're thinking about, right? Smart home assistants. We saw Ron talking earlier about how Google is able to do so much more with TensorFlow now. We see things like self-driving cars, personalized movie recommendations, beating the world-class human players at games like Go and chess. And we think of how great it is. But of course, this is AI at the unicorns. And if you're not at one of the things, and you're thinking about doing AI, you might feel something like this. And I'm curious, to what degree do you guys see this? So raise your hands if you've experienced this at your own company. You can't get permissions to the data. Do you see that? I can see a lot of hands. Our data is too big or too messy. All right, see some hands there. Our ideas work in the lab, but fail to work in the real world. All right? And we have lots of great data and models, but they're not being deployed or adopted. And when you see those things, they're actually very, very common complaints that we hear from our own clients when we work with them. And the ultimate symptoms you get of this are that your initiatives are going to be over budget and underperforming, and your top data science talent is leaving. So what are we going to do about that? Well, let's look under the hood. And if you do, what we'll find out is that what you actually need to really build and scale a data science organization are to make sure that you move up the analytical, operational, and organizational maturity curves. And for each curve and at each step along the way of these curves, you're going to need specific skills. And these skills apply to both data practitioners as well as data executives. So there are different skills for each group, but both groups need to be educated in this. And if you don't have this kind of maturity, what you'll find is that you're going to encounter failure. And this failure won't be immediate, but you're going to see it 6, maybe 24 months down the line. All right, so let's do an outline of the rest of the talk. So we're going to be talking about the analytical maturity curve. This is how your data scientists or data analysts, this is how sophisticated they are at processing data. That's probably the first thing you're thinking of. But we also think about your operational maturity curve. This is the ability of your organization to operationalize and productionalize your machine learning and data science ideas. And the last curve is your organizational maturity curve. This is what managers and practitioners need to know and where they need to be in order to implement this across your organization. And then last, we'll talk a little bit about building a data-driven culture, because I know that's a big theme for the attendees here. So let's dive right in. So on the analytical maturity curve, you've probably seen this before, right? The idea is moving from descriptive to diagnostic to predictive to prescriptive. And it's all about moving from being able to describe what's happening in the past all the way to being able to influence what's happening in the future. Obviously, as you move up this curve, you're going to face greater and greater difficulty. These things get harder and harder. But the value that you derive for your organization gets greater and greater. And that's sort of the value here. At each step of the way, there are going to be different skills that you might need in order to be able to fulfill your tasks. So what we do, data science and AI training, is help companies move along this curve. And with our technical courses, kind of helping them understand how do you move from descriptive to diagnostic to predictive to prescriptive. And it's teaching people everything from basic stats to machine learning to kind of optimization and experimentation. Now, Let me give you an example of why this is important. So the story is actually from a guy named Abraham Wald. He was a statistician based in the UK, but he himself was actually a Jewish refugee in the 1930s. He escaped Austria just before the Anschluss. And he was commissioned by the US Air Force, and he was sitting around in London helping the US Air Force think about its bombing missions. And one day the higher-ups said, hey, we have a bunch of extra steel. We're going to reinforce the bottoms of our bombers. And we only have a little bit of steel. We don't have all the steel we want. So we can't reinforce every part of the bomber. So we have to be selective about what we do, where we put the extra armor. So question is, well, where should we put the extra armor? Now, the natural conclusion that a lot of people came to was, well, we have lots of bombers flying back. We look up at them and we see where the bullet holes are. And where the bullet holes are, well, that's where they're getting shot at, so let's put some armor there. So Abraham he himself is a statistician. He thought about this a little bit, and he came back with the counterintuitive answer of no. You should actually put the armor in places where you don't see bullet holes. And the reasoning is that basically anti-aircraft technology is not very sophisticated. When the enemy is shooting at these planes, they're basically shooting at random. You expect the distribution of bullet holes to be random. And if you see that there aren't bullet holes in certain places, that's because the bullets that landed there actually downed the planes that are now sitting in Normandy in France. So a little bit of statistics went a long way for solving a problem. Very, very high stakes. But it's not always easy to understand your data. And so how does this apply to your company's data? Well, think about consumer survey data you get, or even the behavioral data you're picking up from web or mobile applications. All of those have a natural bias. They tell you something about what consumers in that pool want, but that may not be what's important for solving your mission. And understanding this subtle distinction is going to be very, very important. We also have to really think about the concerns around overfitting. It's very, very easy to do this. And anyone who's sort of watched Kaggle competitions will see how the leaderboard changes dramatically when the final validation set is released. That's a symptom of overfitting. We're in New York. We probably all remember the financial crisis of 2008. That's an example of overfitting, right? The Gaussian copula was probably not the best model for modeling correlations of home prices in these underlying CDS instruments. And even if it were, the sort of regime change that happened for home price dynamics before 2008 and after 2008 are really great. We overfitted to the models from before the recession. Now, some of you might be saying, hey, look, this is really, really hard. What can I do? Well, it turns out that within many of your companies, there may already be a latent talent base that is actually primed to learn more about data science. I call this sort of data analytics 1.0 versus data analytics 2.0. And obviously, there's differences between these two populations, right? Clearly, we're using a lot more data than we used to. Data's coming in much faster. And there's a lot more variety of data. It's no longer just simple Excel tables. We now have unstructured data, semi-structured data, audio, web. And the complexities are much greater now. But the people who have that kind of data analytics 1.0 background, whether they be analysts, statisticians, quants, BI, whatever you want to call them, they're oftentimes the people that we end up training to become data scientists. So we do a lot of courses for companies and also in to the general public. And what we found is that a lot of people who are very good or who pick up this material very quickly, who move into that analytics 2.0 world, they often have an analytics 1.0 background. So a few of the key takeaways. If you really want to get to real business value, you have to move up that analytical maturity curve. And it's also not easy to do that. There's a lot of different obstacles, hidden obstacles, and mistakes in doing your analytics can cost you a lot. Just think about 2008. So now that you have all the analysis, let's think about how you operationalize them. And if you think about the kind of life cycle of a data science project, you're usually moving from exploration to prototype to production to iteration. And again, the value comes maybe when you get to production, but really at iteration, right? Because it's great to have one model that does really well, but the signals in that model decay over time. And you're going to need to retrain and reiterate on that model, improve on it, change it as your underlying data schemas are changing and evolving with your business. So how do you move up that curve? And how do you think about the skills you need to do that? Well, there are, again, multiple steps along the way, different tools that you may think of as you're thinking about how do you move things to production. And let me give you one very interesting example of how important thinking about the operational maturity curve is. So how many of you have heard of the Netflix prize? Raise your hand. All right, that's most of you. For those who haven't, basically Netflix, this is back in the mid-aughts, was offering $1 million if you could take anonymized user data and build a recommendation engine for their DVD service. They were using a DVD service back then. And if you could improve their recommendations by 10%, they would give you this $1 million prize. And they ran this contest actually for multiple years. Lots of people all over the world were collaborating on this. It turned out to be one of the really big galvanizing contests that kind of re-energized the interest in machine learning. And eventually, the team from Bell Labs won. It was this Bell Core team. They got their $1 million check, as you can see here. A large amount of fanfare. I think that's even Reed Hastings standing there on the left, right? So you'd imagine this would be great. Now they have this super duper recommendation algorithm. They're going to implement it, and they're going to knock everything out of the park. The only thing is they didn't. So clearly this was a really important algorithm for them, right? Like, you don't have the CEO standing there writing $1 million check if it wasn't important. The problem was actually that the model was too complex. And that's not to say that Netflix is an incompetent organization. It's actually very capable, as I'm sure you've realized from the talk earlier today. But it's actually really too hard for, the model was just too complex for them to practically operationalized. It was some ensemble model, had hundreds of different components. Each component had multiple subcomponents. And building it all out in a research lab where you have to train it once, get your prize money and leave, that's one thing. Putting it into production where you're using it day in and day out, retraining it constantly, it's another thing. It's a very different challenge. Here's sort of a basic schematic. I stole this from one of the class notes we have around what it takes to do production of AI or machine learning. And a lot of these things probably look familiar, right? You have your raw data. It's moving into your x's and your y's, so you're setting up your features and your target variables. You're going to train that, move those models in production, so you have to cross this barrier, this dotted line, between your scientific development environment and your production environment. And as you move it, and then you have to, of course, move a lot of your data back and forth as well, because you have to move your data from production into training. And then the very end of this, after you've iterated, you have your value. And you figure out what the value is, but now you have to pump that back into analysis. Because as we know, sometimes when you run things in experiments, you don't get the same result that you did in training. And it's this constant iteration process, right? Where you take the results you have, iterate it back, and train. Think about how many lines there are. Every line could be another ETL job. And some of these lines have to cross environments. So do you have good protocols in place to make sure that you have strong data hygiene, to make sure the same versions of libraries, data schemas across these two environments? Do you have all this set up in an automated way so that deployment is push button? All of these are really, really important things to consider. Huh. OK, apparently you can't convert from Google Slides as easily as one might have hoped. But so as we think about this, one of the things we have to really, as we think about operational maturity curves, one of the things we have to really think about is hygiene. And we like to break up hygiene into 3 categories. Your data hygiene, right? Making sure that your data is the same thing in production as in research. If you're feeding bad data in, you're going to get bad results out. The next thing to think about is probably model hygiene. How do you make sure your models are versioned? You can easily roll back and forth from one version of the model to another if, for example, your experiments are showing that the new version of the model is hurting performance. And of course, code hygiene, right? Keeping all this stuff in Git or some other version control system so that you know what's happening and you can, at any given point in time, just look at a line of code and get blame and figure out who committed that, right? All this stuff is very, very important. And of course, it means that you need data engineers as well as data scientists. And that you need, a lot of times, though, as you're thinking about building out your data science teams, the operational maturity curve has to come a little second, right? It's wonderful to have all the perfect infrastructure the day you show up as the first data scientist, but that's kind of hard. You often have to do a lot of analytics without this kind of support initially so that you can show some initial results, get some traction, find some low-hanging fruit, deliver value, and use that as your feedback cycle to the business to get more traction. And that's, but it's also important to remember that you have to start moving along this operational maturity curve pretty soon after you start getting that traction, because otherwise you just won't be able to fully realize the value of these data science projects. They just won't get into production. All right, the last one we should think about is the organizational maturity curve. Now, the organizational maturity curve is really moving you from enthusiast all the way to embrace. So this is how an organization thinks about data. When we work with companies, they're typically at the awareness and initiative stage. They've started moving beyond just having a few pockets of enthusiasts throughout the organization, doing little bits of data science here and there. And there's a sense that, oh, maybe we need to allocate some funding to this. Maybe we need to get more people behind data science and move the organization in that direction. And you can look here and think about, well, where's your organization in this organizational maturity curve? So if we master that, if we get all the way to the end of this maturity curve, we can achieve all the potential that we had before. So we can build our Alexas and our self-driving cars and our bots that will beat humans at world-class humans at games like Go. But more often than not, for organizations, they fall short of that. And when they fall short of moving through the organizational maturity curve, you get stories like this. And I've pulled out here a few kind of very high-profile cases. And I don't mean to sort of beat up on tech giants, but I think it's important to think about how even tech giants, who are probably some of the most organizationally sophisticated players when it comes to AI and machine learning, how even they kind of trip up and encounter problems. So I'm sure you've all heard of the story around Microsoft Tay, so I won't go into that. But there have been a number of other instances where, for example, Google was doing translations from Turkish into English, and in Turkish, the third person pronoun, which in English is either he or she, in Turkish it's not marked for gender. And when Google does the translation, it would automatically assign a gender, but rather than just consistently choosing he or she, it would do so based on the context of the sentence in a way that was highly sexist. And you can sort of read more about that. There was, Amazon did a bunch of research into resume screening, building internal resume screening for their own systems. They found out that it actually discriminated against women after looking at it for a bunch. And after 2 years of effort, they actually ended up canceling the program because they realized they just couldn't get it to be not sexist. Facebook is kind of, has been in the news quite a bit, but one of the things they did was allow ad targeting towards anti-Semitic groups. And the way that this happened was they said, well, you can target to any affinity group. So I like Ford, or I like tortilla chips. Both of those are groups that have a lot of followers. And they said, well, any group that has more than X number of followers or X level of engagement, we're going to let you target ads to. And without really sort of reviewing or thinking about that very carefully, they accidentally picked up groups that were hate groups. And it's because those, unfortunately, have a lot of interest and get a lot of engagement. So these are some of the risks. And I think that if you sort of step back and think about it, obviously, if you step back and think about it, how do we think about addressing these risks, right, in our organization? And as you move along that maturity curve, I think part of the story has to be, well, your data scientists are probably going to have to get a little bit, be a little bit more trained, understand this a little better. But a lot of these problems are very, very domain specific. And I would say that actually the thing that has to happen is that your managers, whether they be product managers, business leaders, executives, they have to get more trained and be more savvy about data science. So I guess I'm not alone. McKinsey did this survey a while ago. They said we're going to need 140 to 190,000 data scientists and analysts, but we'll need 1.5 million data savvy managers. There's actually more of a demand for non-technical people who are learning data science than there is for sort of technical folks. And actually, so we do a lot of, what we've seen is this is actually very true. The course that we offer that has the most sort of draw right now, that's growing the fastest, is a course called Data Science for Business Leaders. And it's a non-technical course geared towards executives. And the idea is that we're not going to teach you how to edit a Jupyter notebook and write Python code and train up TensorFlow models. That's another set of courses that we offer. This is really trying to teach business executives the fundamentals of data so they can understand, well, this is how you might want to think about data science very broadly and AI broadly, so you can be intelligent and come with good questions to meetings. So, big takeaways from this, I think AI risks are business risks, right? We saw that slide about some of the missteps that some companies have done. And so you can't just sort of say like, hey, this is some technical problem that I'm going to outsource to all the technical folks out there in the room. It's actually very much a business risk. And as a business owner or as a business manager, you have to think about what you're going to do and what your strategy is to mitigate that. And a large part of that is the need for data literacy. Again, not just for the data science team or the data analysts, but throughout the organization. Even the non-technical people now need to become much more data and AI literate. Of course, that's kind of driving us towards these 5 building blocks of a data-driven culture. So this is a piece that I actually co-authored a while ago with Carl Anderson, who is, maybe he's in the audience? Well, I know he's here because I saw him earlier today. And we're talking about what does it take to build an organization like this. And we're talking, there are things like a single source of truth, consistent and up-to-date data dictionaries, broad access to data, and strong infrastructure. So you need to be able to access and run your workloads without having to jerry-rig something yourself on AWS. Obviously, data literacy, we were just talking about that, and having that spread across your entire organization, not just the technical side, but the non-technical side. And ultimately, kind of data-driven decision-making. And I think we've heard a lot of good talks about that, avoiding hippo syndrome, that is the highest paid person's opinion, and focusing on using data to solve your problems. So if you have any questions, feel free to come bug me. You can see my Twitter handle and my email. And yeah, I'll leave it at that. Are there any questions? Go ahead. Why don't you stand up and say your name?
What are your thoughts on citizen data scientist becoming real data scientist?
Mic check.
Yeah, that's a really great question. Look, I think data science is a wonderful thing, and we should spread that knowledge as much as possible. I do think that there's a lot you have to learn to become a data scientist, right? So I feel like most people who are data scientists have a PhD, which isn't to say it's necessary, but there's a lot of years of training that go into understanding the math and the programming and all these other aspects of it. And so saying that you're going to come in with no quantitative experience and that you're going to get to become a data scientist, well, that's going to take time. It's not saying it's impossible, but it'll take time. I think a lot of what we've seen is the people who are going to be hands-on practitioners, they often have kind of this data analytics 1.0 background, right? They've done some proto-data science thing before, or doing some sort of proto-data science thing. And it could be something as simple as, a lot of people we have are sort of analysts, let's say, on kind of Wall Street or sort of for some business function in a large corporation, and they work with Excel all the time. And they just, they deal with data in and out every day, and they realize the limitations of that tool. So what they're learning, what they're coming to us for is learning how to use Python or something that's a bit more programmatic, so they can automate their workflows, they can do something more sophisticated, they can start working with unstructured text or textual data. And I think that's maybe a bit more realistic of a path for becoming a data scientist. But obviously, even for people who aren't technically inclined, let's say, there's still an important need for data literacy. And I think that falls much more in line with the kind of business executive education that we're doing around data science for business leaders, right? Teaching people who aren't data scientists and who are not going to become keyboard ready. How do you think about data? How do you how can you use data in your organization? Well, how have other companies used data? Questions like that. So thank you, that was a great question. Anyone else?
Yeah, I have a quick question here.
Go ahead. Say your name.
David Mantia. I have a question about, I guess in your client base, like how, I'm kind of curious, oftentimes you see in job postings, people saying we need data scientists, but it's really a glorified BI analyst, right? So I'm wondering how you kind of like communicate the difference and deal with that kind of aligning expectations.
That's a really great question. And are you asking that question more from the perspective of as an employer or as a potential employee seeking employment?
As an observer, basically.
As an observer. Oh, I don't know. I mean, I think I think the answer sort of depends on what is your objective, right? If the communication isn't clear, you make the communication clear by thinking about what it is you want to accomplish. So, if you're a data scientist and you're thinking about this, then it's, well, you got to read the job description a little bit more. And, people may lie on job titles, but they're not going to lie on salary because you're not going to pay, full-blown, somebody who's just a data analyst what you would the salary you would a full-blown data scientist, right? So I think you'd probably look for things like that. As an employer, I think I guess it's this interesting cat and mouse game, right? Like, which group are you trying to appease? I think when you merge those two or conflate those two categories, what you end up doing is you make the people who maybe would be called data analysts happy because they suddenly get this much more prestigious title, and you make the people who are data scientists less happy because now all their experience is being conflated with other this other group of people who are doing very, very important work, but it's sort of it's different and a different set of skills than what the data scientists are doing. So I think that's kind of a tricky thing, and you're right, there is a bit of sort of buyer beware, right, when it comes to job titles. Anyone? Oh.
Hi, my name is Pablo. You showed several like technology adoption and progression curves. In your experience training companies, are these curves relatively smooth, or do you see more like bifurcation points where some companies do X and they take off, and some companies don't do X and they fail to adopt?
No, that's a great question. So I think we see that when companies try to let's say, implement AI or data science or ML, they succeed if they can move through these curves. If they don't move down, usually people kind of understand the analytics curve, right? But I think the operational and the organizational are a bit hidden from companies, especially from management. And so you'll often see this symptom of, hey, my ideas just aren't getting into production. Well, that's because you don't have the right kind of production environment to be delivering data science. And you don't really know that, and you're kind of moving through and banging your head against the wall without sort of stepping back and looking at, hey, actually there's this major step that we have to do in terms of productionization of ML, and that's going to require a much larger lift than our current strategy. Or, hey, it's great, we have all these models, we can deploy them in production, but the business side is really, really afraid of implementing them. And there's a bit of algorithm phobia, I think we were talking about earlier, right? Or algorithm aversion. So that's part of the organizational maturity, right? It's like, how do you bring in these different stakeholders who are not necessarily data experts and get them to appreciate what's happening on the data space and buy into what you're doing as a data scientist or as a data group. So that's a great question. And I think I'm out of time. But if you want to bug me, I'll be here for a little bit longer and happy to answer your questions. Thank you.